So as we look at specific landforms for the rest of the term, we're going to use topographic maps to evaluate the type of landform, the movement that's happening, and use that as part of our analysis. So when I talk about relief, I'm talking about the change in elevation from one location to the other. And this could be local relief, like in Eugene, the difference between the valley floor and Spencer's Butte. Or it could be the relief of an entire country from sea level up to the highest point. And that idea of relief provides that three-dimensional quality of an image. And so if I look at a profile or a cross-section in Oregon, this would be showing going up the mountain. You've got high relief here and coming down the other side, that idea of relief. So topographic maps make use of ISOLINES, and we looked at ISOLINES when we talked about Isobars for air pressure. But we're going to be looking at elevation lines or contour lines. And the elevation line is just a line of continuous elevation, so with no change. So if you remember, you looked at isobars, and if you had a high pressure system moving in on a low pressure system, everywhere you were on the earth along that line would have the same air pressure. And when the lines are far apart, the air pressure is not changing very much as you go across the landscape. Where the lines are close together, the air pressure is changing rapidly. So to create contour lines, you have to think about spot elevation being taken where somebody goes out. Right now it's probably done more with LiDAR and satellite imagery, but or high mid-altitude flights. So that elevation points are taken across the landscape, and then these are kind of extrapolated into lines of similar elevations. So you can see here there's a kind of a connect the dot idea. So here's 40 feet in elevation, and that's higher than 38 feet and lower than 47 and 45 feet. So a line is created to connect all the points on the landscape that are about 40 feet in elevation. And then another set of lines could be created to show where 30 feet in elevation is. Until you have continuation. So let's think of this as a little island, is a very flat, shallow little island because it's only 45, 47 feet above sea level. But ideally, if you were to walk around this zero contour line, you would be at sea level and never change elevation as you went. Then you could walk upslope 10 feet and walk around the island at 10 feet above sea level and never change your elevation. Walk up another 10 feet in elevation. Now you're at 20 feet above sea level and you're walking around. So these are continuous lines of elevation. So we can look at this. In the lower right-hand corner is kind of the aerial view, a little topographic map of an island with 3 small prominents on it, or 3 little mounds on it. And you can look at it in cross-section. And in this image, our difference between contour lines was 10 feet. That's called the contour interval. On this map, the contour interval is 500 feet. So here I'm walking around at sea level at 0 degrees, or at 0 feet above sea level, and then I'm going to walk up to this next contour interval, and here I should be walking at 500 feet above sea level. If I walk up to the next one, I'm walking at 1,500 feet above sea level, and so on. But if I don't want to go uphill, I can just walk along that contour line theoretically and never change my elevation. Contour lines help you understand where the land is has a steep slope or a gentle slope by the proximity of the lines to each other. So just like isobars, when you had the lines far apart, there wasn't a lot of change in air pressure. In a contour map, if you have lines far apart, there's not as fast a change or as steep a slope as you go from one side to the other. So this western side of this island, or southwestern side of the island, it's a pretty gentle slope up to the top. That's the way I would walk it. On the northeast side of the island, you can see these contour lines are a lot closer, and that indicates that this is a steeper slope or a cliff. And you can see that in the cutaway 3D image here. That's a pretty steep slope compared to that slope. So the contour lines give equal elevation. The contour interval tells you how much change is between each of these contour lines as you go up in elevation. On a topographic map, a USGS topographic map, the contour lines are assisted by what's called an index line. And an index line is a boulder line, and usually every other or every fourth contour index line has the elevation mark on it. So this elevation is 1,200 feet above sea level. This elevation is 1,600 feet above sea level, and I have 1, 2, 3, 4. So each one of these lines is 100 feet. So there's 1,300 feet, 1,400 feet, 1,500 feet, 1,600 feet, 1,700 feet, 1,800 feet, and I can see just the edge of 1,900 feet, so 1,900 feet above sea level. And each of these smaller lines, the contour interval here is 20 feet. So if I wanted to know the elevation of this beginning of this little stream, I could go to the index line. So this is 1,300 feet, and then there's another 20-foot contour. So the headwaters of this little stream would be 1,320 feet in elevation. Sometimes topographic maps have what's called a spot elevation, and often at the top of mountains there'll be a triangle or a dot with the elevation written right beside it. So at the top of Spencer Butte in Eugene, the elevation is 2,054 feet. Here is a small mound north of Springfield. So you can see that there's a spot elevation here saying that the top of that little mound is 1,102 feet. The bottom of this by the river is 40 feet less than 500, so 460 feet in elevation would be about the elevation of the shoreline here, and here's a water elevation at 451. So 460 feet, and then the top of this hill is 1,120 feet. And you can see that this side of the hill has a much gentler slope than here. These lines are almost touching each other. This would be a very steep area. When I ask you to calculate relief, I'm asking you to tell me what is the relief from one point, or what is the difference in elevation from one area to the top of the feature or to another area. So for example, I might ask, what is the relief of Spencer Butte from the parking lot? And so the parking lot picnic area is right here. Here is the 1,200 foot contour line. So this is the 1,300 foot contour line. So I'm going to use that as the bottom elevation, so 1,300 feet. And this has a contour elevation, spot elevation of 2,054 feet. So I just subtract the two, and my elevation for Spencer Butte is 754 feet. You have to put the units in your map. If you just have 754, that's incorrect. So you want to make sure that you're adding units when you do your contours. So I'll include a practice sheet in the reading, and then we'll be doing a little bit of contour reading for the rest of the term.